Welcome, I'm Bill Wake. This is my summary of the work we've done on Twitch this week. We're continuing to work on this Dulcimer Player app with various tools, and this week we focused on persistence. So we only had 2 sessions because of the holiday, but we made our classes use query and model, which is SwiftData's approach to persistence. We removed some unused functions from the library. We improved our sorting a little bit, and we started working on making library and song decodable so that we can do an initial load. Let's see a demo and take a code walkthrough. To see persistence, we're going to mark one of our songs with a date played. So song 3 DAD, and we mark it. And now if we quit the app and then restart it, song 3 DAD still has 12/29/2024. So this lets us know that the persistence worked. We completely closed the app. Before, it would have deleted everything. We'd start with a totally blank slate. So there you go. So with SwiftData, you have some changes to make in the app, but it's mostly similar to what you have. The big thing is you start at the app level and you create a model container, which is basically the database context for this thing. And it knows it's going to be mapping the song class because we say song.self here. All right. And then to use this, well, let's look at song first. The big thing you're doing there is you declare it as @model. So it has to be a class. Ours was a struct before, and we switched it over to a class. And you declare @model. That ties it in so that the persistence knows what class to focus on. Now to use that, you do a reference, and we're doing that in our content view, which is kind of our top level view. With @query says pull out the, load in all the songs basically. We could add filtering and sorting on this, but we're just keeping it simple for now. And this will be maintained. The relationship of this thing will be maintained. If we add something or delete something or change something, this gets mapped back to the database system, so it's all persisted. The other change we made around this is we had library was originally what our content view held, and library holds the list of songs. So basically the persistence kind of likes to focus on the list of things. So we still keep this around to do wrapping and processing on it. Some of our key queries, well, our main queries, one of which is keys. Given that collection, what are the keys in it? Well, we can answer that. Also, we want to know about the songs. We want subsets of them filtered and sorted, and we're doing that at this level, in the memory level, not at the database level. I think you probably could, but this is where we are now. We may investigate that at some point. All right. So the big thing is we filter based on the key. So key of G or key of D or whatever key we're in musically, and then sort it by name. Now Swift sort is stable, so we sort by name as sort of the secondary sort, and then filter based not on the key but on the filter text. So if they look for joy, well, there's a song called Soldier's Joy, and the name Soldier's Joy lowercase contains the text joy. And if there's no filter, the filter text is empty, then we'll just accept anything. And then finally we sort by the order, the main order that we want to do. Okay, and so those are all managed by song order, and it's basically an enum with the various possible sorts we have by name, by tab, by source, last played, whatever. And those are passed in here to tell us how do we want to sort. So the core of that is there. Then we did some work on our sorting function, and we pulled out the precedes function. So normally if a sort, you would let the less than operator mean how do you sort. But with the ordering, we have lots of ways we want to sort. So we need to distinguish them. I'm not 100% sure song order is the right place for this, but you could conceivably put it on song as well. But it's kind of nice to have it together to say, if you're doing last played, how is that determined? Okay. And most of these are ascending, but a couple are descending. And unfortunately, I don't think our widget lets you reverse that. We're going to look at that at some point. But in any case, all the ways you can sort show up here as comparisons. And then when you do the actual sorting, we know where that function or what's function to use, because the song order precedes function, returns you a function. Each of these is a lambda function for comparison. Let me go to where this is used. All right, so in song, we extended array of songs with a sort method that uses the one determined by the order. Finally, we had a feature before that would load in the initial set of songs based on sort of a standard jam list overlapping what many clubs or groups would use. In the process of putting in the SwiftData, though, there's no provision there for initial loading. So we're going to have to do some work to load those initial songs again. It'll load what's in the database, but the first time it doesn't have anything to do that. So we're making persistence. We're also using like JSON decodable persistence. So with that, we mark it decodable. We may need to mark the coding keys. These correspond to names here, match names here. And finally, we have to have an initialize method. Given a decoder, how are you going to pull this out? Well, basically, we walk through and pull each individual field out. And that will let you create a song from the JSON, basically. So we have that full thing. We also using the library for this. So originally the library was a decodable struct and knew how to pull in the songs. So we're keeping that function. It just has to know the one field it has is the songs array. And because of the way things get mapped, it turns into underscore songs in the JSON file, but we'll live with it. Okay. And with this one, because it's a struct, just mark it decodable, and knowing that song is decodable, it can generate the decoding stuff. With this one, we had to write with song, we had to write that initialize function. I think it's I don't think it's the class. I believe it will generate them for classes or structs, but I think with model, there's a macro that kind of rewrites everything, and I think it destroys the ability to do these directly. It's not hard code, it's just tedious. We have a bunch of fields and we go through one at a time doing the same thing. So there's no reason we wouldn't want that done by computer. Coming up during the holidays, I may do some unscheduled user interface work. We have this grid at the front page, and it's not really very flexible, so I kind of want to do that. And then when we're back from holidays, I want to start the initial load from that JSON file, so that when you first run your system with no database created yet, we load that file by default. All right, now I am off for the holidays. We'll return Monday, January 6th, Monday through Thursday, 2 to 4:30 p.m. Eastern Time, or 7 to 9:30 p.m. UTC. If you go to xp123.com/Twitch, you get the live session if we're there. And if you go to xp123.com/YouTube, you get the older sessions, time delayed and lightly edited. And I may run out of sessions before we get through the holiday. I'm not sure how many I have, but it's usually a week or two behind. Thanks for watching. I hope you can join us sometime. Bye-bye.